Hello everyone, I have a little bit of time and homing shots are something that I did for my project at work recently, so I thought why not make a tutorial out of it. I know that there are some tutorials on that topic, so hopefully my approach is unique. And this is the whole code. You can just copy it if you want and it should give you the results that I've shown, but I'm going to describe it for anyone who's interested. Direction is pretty simple, just a vector from your target to the point from which you are shooting. Imagine a straight line from point A to point B. You need to normalize it, and what it does is it makes sure that the length of this vector is always 1. Otherwise, the results will be weird. Rotate amount is a bit more interesting. Let's start with the vector free cross function. What it does is it returns you a vector that is perpendicular to both vectors that we put as parameters, in our case the direction and transform.up, which is pointing upwards. But if you leave it like that, it won't work correctly because vector-free cross works based on the world space, and in this case we need it to be based on the local space of the projectile we are shooting. For this we use inverse transform direction function, and this function makes sure that this vector is relative to our projectile. And then we take the z coordinate. Imagine that green dot is our target, this black circle is our projectile. If our target is right in front of our projectile, then direction is going to be vector 0, 0, 1, z is 1, and our vector free cross inverse going to give us a vector 1, 0, 0. So z is going to be 0 if our target moves, let's say, to the right. Then our new direction is going to be new vector free cross is going to return something like that, again perpendicular to our vector. That means that our z value is going to be, let's say, minus 0.5. And then we say that each frame, or in my case each fixed update, our angular velocity of projectile is going to be equal this amount and multiplied by the value which you choose. This value will dictate how fast your projectile turns, so how hard it is for maybe player to dodge it. And finally, we always move our projectile forward, transform forward, and again multiply it by movement speed. This will only work in one plane of movement. If you want to work in every plane, you can also do basically the same thing, just for another axis. You can see the code here. For my project I don't need it. Now I'm going to demonstrate with arrays what I've just tried to explain. As you can see, our blue vector is direction, black vector is vector free right relative to the sphere, and red vector is vector free cross. If we move the player, you can see how now our cross function returns negative z value, so we start rotating the sphere accordingly. And when it points to the player, our vector free cross again returns 0. We stop rotating the projectile. So that was my full explanation. Maybe it helped someone. I would hope so. I did not expect that it would be so difficult to explain. It was easier to code. Anyways, thanks for watching. I'll see you next time.